Hello students, welcome to the next lecture on the June 2023 mathematics. Today we will discuss about all those questions related to the ordinary differential equation in the year June 2023 mathematics. Myself Dr. Harish. You can simply follow my YouTube channel where you can find the various updated videos, and you can simply scan and join my WhatsApp group through here where we will discuss the various shortcut tricks and the various parts. What we have discussed so far is we have discussed the Markov chain, partial differential equation, calculus of variation, integral equation, real analysis, as well as the complex as well as the linear algebra questions of this June 2023. Now today we will discuss about ordinary differential equations. So let's start with this. There are the 5 questions which is related to this initial value problem. This is the ID number 42, 47, 92, 91 and 93. These are the 5 questions which is of, this is the 4.75 marks, this is 4.75, this is 4.75, this is marks 3, this is marks 3. Now these questions are very easy. If you remember my shortcut tricks which I have explained in my previous lectures related to the PY questions of the differential equations, here PY question of the differential equation, then you can solve these questions within a fraction of a second. So let's start with these questions. Now what is that? I already told you many times that whenever you have the system of the equation where A is my matrix, find the eigenvalue of this matrix. What is the eigenvalue of this matrix? Is this plus 10 minus here. So the eigenvalues are 1 and 6. So therefore your solution will be C1 e raised to power t plus C2 e raised to power 6 of t. These are the eigenvalues. Now look at the option. So where C1 and C2 are any arbitrary constant, because initial condition is not given to you, so it may have any value. Maybe both are 0, maybe both are negative, one is a negative, one is a positive, and so on. Xt is a bounded function. What is the meaning of the bounded? So that is a mod of this is less than of some m. But here you can see e raised to power t is an unbounded function, because t is my positive. If t is my positive, then it's unbounded. If t is negative, then it's a bounded. But what is the C1 and C2? It is not given to you, so it is not always correct option. Look at that, e raised to power minus of 6t into x. What is that? If you multiply this as, it will give you a e raised to power minus 5 plus c of t. He said as t approaches infinity, it goes to the 0. So generally the student may think about that. Look at that. When t approaches infinity, this part goes to the 0. But we will get as the C2. C2 may or may not be a 0. So it means this is not always goes to the 0. Look at the third option, e raised to power minus of t, which give you as a C1 plus C2 e raised to power 5 of t. Now, as t tends to infinity, it goes to the infinity. As t tends to infinity, this may or may not goes to the infinity. Why? Because C1 and C2 can be anything. If I say C2 is a 0, then this expression will converges to the C1. If C1 is not 0, then it will goes to the infinity. But there is no condition given on the C1, C2. So we can never say it is always goes to the infinity. So this option is cancelled. Only left option is 1. That is the right answer of this problem. How? You can see e raised to power minus of 10. So it is my e raised to power minus of 9. C2 e raised to power minus 4t. So as t tends to infinity, this part will always goes to the 0. So irrespective of the value of the C2, this is always 0. Same for here. This part is always 0. So whatever the value of the C1, this is always goes to the 0. So hence this is my correct statement of this problem. That's a very simple about it. Now look at this another one which is related to the boundary value problem, and this is the integral equation. So you can solve this problem with the help of the integral equation as well as with the help of the ordinary differential equation. A very simple question about that. So because this is the solution corresponding to this here, what you can do, I can choose the first option, substitute here, I can think about whether this satisfied or not. So since because there is only the one correct option, so it's quite easy to satisfy them. Now I can break this interval from 0 to x is t times 1 minus x of y plus 2 times is a common, so it's a 2 times x to 1 x of 1 minus t of y of t into dt. Now what you can do, you can find the first derivative. So what is the first derivative of the partial derivative? It's the minus of t yt into dt plus upper limit x 1 minus x y of x into 1 minus lower limit 0 plus 2 times partial derivative with respect to x here plus upper limit is a 0, lower limit will be x 1 minus x y of x into 1. This will be cancelled out. Now find y double dash. What will happen? 2, there is independent of the x, so the integration will be 0. So it's a 0 plus upper limit, so it is a minus x y of x into 1, lower limit is a 0 plus 2 times, again it is independent of the x, is a 0, upper limit is a 0 because 1 is a constant value, minus 1 minus x y of x into here. So what is that? It's a 2 as a common, minus x y minus y plus x y. So it is a cancel out, it is a minus of 2y. So y double dash minus 2y, which satisfied this property. Now look at that, y0 is satisfied. What is a y of 0? 0 to 0 is a 0. 1x is a 0, it's a 0. So y of 0 is 0 satisfied. What is the y of 1? When y of 1, 1 minus 1, 0. 1, but it's a 1 to 1 is a 0. So this is the right answer of this problem, as answer is my first is the simple correct option. So there is no need to solve the other. But if you try to solve this one, then definitely this term will not be cancelled out. So you will get as a simple expression. Now look at this is the part C. And this shortcut tricks I already told you many times. Whenever you have the differential equation of say u dash is a u of alpha, where b of beta is my 0. So remember, this solution has a unique or this solution has a infinite solution. When? So first of all, unique solution when a will be less than 0, alpha belongs to my 0, 1 and beta is my any real number. Infinite solution when a is my greater than 0, alpha is lies between 0 and 1, beta can be any real number. So look at that. This is my beta, which is 0, which is a real number. This is my alpha. Alpha is lies between 0 and 1. So look at that, t square. T square is always greater than 0, whatever the value of the t from the domain. So it means it satisfied this property. So it means this u has infinitely many solution. So second option is cancel out. It exists more than one solution of the initial value problem is the right answer. Now look at that. The function g, that is this function, does not satisfy the ellipsis condition. So if I take the partial derivative with respect to u, it will be 5 u raised to power minus 4 by 5. You can clearly see this does not exist around or at neighborhood of the 0 because it's a negative sign. So what is the meaning of that? Ellipsis condition not satisfied, and he said does not satisfied. Correct option. This is the same function, satisfy the ellipsis condition is the wrong option. So the right answers are my 1 and 3rd are my correct options. Look at the another one. F is my bounded. What is a C1? This C1 is means that is a continuously and differentiable function plus a function is given as a bounded as well. Can you think about any of the function which is a continuous, differentiable and bounded? Constant function. Every constant function is differentiable, every constant function is continuous and bounded as well. So I can simply take f is my 1. Then which of the following is there? So if I look about that, x dash is my 1. So what is the meaning of that? If I integrate them, dx is my dt. So solution will be x is t plus c. x0 is 0. What is the meaning of that? C is my 0. Solution is my here. So since this is independent of the t, so it will give you a unique solution. So it means it has a unique solution. It has infinite many solution, cancel out. If instead of this one, if you think about any of the other function, like say cos of t, it is also bounded, is also continuous, is also differentiable. then your x dash is my cos of t, then your integration will be x is sine t plus c. When x0, t0, c will be 0, so x is my sine t. Again you can see this is my unique solution. So you can think any of the bounded function, continuous differentiable, you always get a unique solution. P has a solution defined for all t greater than 0. Now you can see this solution is defined for all t greater than 0. This is also correct. Again you can see this solution is defined for all t greater than 0, because either you can take about this example or this example. This is also the correct option. The solution of P satisfies the Lipschitz condition. What is the Lipschitz condition of this? If I consider solution of this, so solution of this, if I take the derivative of solution satisfy the Lipschitz condition. So what is that? This is 1, which is a bounded. Look at that. If I take of this is cos of t, which is a bounded function. So it means the solution also satisfies the Lipschitz condition. That means your target is to prove x dash is less than of something. This is the first method you can do. Otherwise, look at that. What is given to you? X dash is my f. F is my bounded. So if I take the modulus value on the both side, f is given to you as a bounded. It means this is less than or equal to m. What is the meaning of that? That means x. What is the x is? What is the x? That's a solution of the initial value problem satisfied Lipschitz condition. So the right answer of this problem is 1, 2 and 4 are my correct answers of this problem. Look at the another one, which is a similar question of this here of u of alpha, where u times beta is my 0. Remember, it must be the 0. It must be the 0. Clearly says that for the p case, what is my a? A is my 1, which is greater than 0. So therefore, P will give you infinitely many solution. For the case of the Q, what is my A? A is my -1, which is less than 0. So Q has a unique solution. Because alpha in this case is a half, in this case is half, both belongs to the 0, 1. So P is my infinite solution, Q is my unique solution, rest options are cancelled out. Correct options are 2 and 3 are my correct options. So have you analyzed that? I have solved all those questions, all these 5 questions with the help of the simple trick that I explained in my previous PYQ question video. So these are the all 5 questions. I hope you can simply learn, and it's a very simple paper of the June 2023. We will see the next questions video related to the integral equations. Till then, I hope you can simply watch my previous year videos as well as the simple questions related to the June 2023 and share with the others. Kindly like, share and comments as much you can possible. Thank you very much, students. Happy learning always.